have a sealed lead acid battery. These have been discharged and left discharged for quite some time. I hope you can see the meter reading. Right, you're going to have to trust me on this one. I'm not holding it and struggling around. Right, so you've got 1.61 volts on the battery side. So what we're going to do is we're going to use some chemistry and see if we can revive it. Now typically, if you've seen the plates on the other one, these have a mat in. Now they're called glass mat, but they're more like kitchen roll, and it's sort of, you know, a dense fleecy material made like paper that soaks through, and you get a carbon plate and a lead plate. Now the lead plates usually stay perfectly fine apart from the carbon plates, because of the way they're made to get capacity out of them. They're quite a soft chalky material. So what we're going to do is we're going to mix up some sodium hydrochloride and pop it in each of the cells to clean off the sulfate. I don't think it has got sulfate on them. It's more likely to have damage to the carbon plates. So we've got a bit of salt, sea salt, a syringe and a battery, and guess what's going to happen? Yes, you're right, we're going to suck some of the solution up. Oh, maybe not. Oh yes, we're going now. And we're going to inject this into the cells. This is really awkward trying to do it with one hand. So I thought, well, they've dried out all the cells on the battery. So they don't take much in at first, because obviously it's got to try and soak into the actual battery. This is quite warm water. It's out of the boiled kettle. It's been sat for a little while. My coffee's actually gone cold out here because it's about 1 degree Celsius, not Fahrenheit obviously. So what I've done now is they're all full up. And I'm going to pause the camera and give this a good shake. I'm going to put caps on it first though. So basically what I've done then off camera is I have drained out this as much as possible, getting out all the sludge. Let me put this onto the light. Yes, that's how clear it is. It's not out of focus, it's just very blurry. So what you get is we filled that off, let it go settle, and about 400 milliliter, 400 mils into each of those. Couldn't really get them really dry though, which was a bit of a pain in the neck. So we went upside down, shaking up and down. There was everything everywhere. Turned it off into a bucket, because of course we make hydrochloride gas. So let's. I've got it on charge now. It's on overcharging. So it was just at 11.7. I can't get. I should eat more Chinese food. So we're setting about 11.71. It's climbing. It did climb up, obviously it's 1.6, so we're going to leave this on charge for about an hour and give me time to charge this camera up as well. And then what we'll do is we'll switch it off, leave it overnight, voltage check it in the morning, and then we'll put it on a equalization or recombination charge and see what happens. So just a quick update before I go in. Left it on charge and I flushed it again, and we went from 10 to 11 point something or other. So what I've done is, so I can get the voltage up and start the recombination process, I put it on my solar system. I've got a constant voltage, constant current system here, look. So it's late in the afternoon, we're in the UK, it's January, not getting that much power for it, but this will give it the voltage that it needs to start gasify. But can't really hear anything, so I've got the camera up close, which is why you can't see anything. Yeah, I can hear it, it's starting to bubble now. So we're going to leave it like this for a while, let the sun do its magic on it. It's at 15.37 volts. I can't leave it on this for long because it'll start damaging the plates, but it should start it gasifying and recombinating, and then we'll see where we go. When I did take it off charge, we had something like 2.8 volts. Obviously it didn't get up to capacity, and it was dropping, so we'll see how this goes. So a little bit later in, okay, you can hear that we've just added our hydrogen peroxide to the mix, and as you can see, oh, there we go, we're starting to bubble now. We're using 16 volts. The current's really low, so we're going to bubble over shortly. This is quite common as it expands, so I'll just pause and sort this out before we make a mess. So what I have here is a voltage and amp meter connected to the battery, so it goes from that buck converter down to the battery. So let's just zoom you in. As you can see, this is the voltage and the current going through it. Now this battery was at 12.2, and as you can see, this is the, I'm going to adjust the current, and as you can see, it'll take a while before I can adjust it down past the 1 amp. Come on, there we go. So 0.7, 0.6, 0.8, 9, 1 amp, 1.2 amp, 1.8. You can see the voltage changes as well. There we go, and I hit the cap at 120. I can't add any more current. So look at this. I'll wind this off again. This time I'm going to change the voltage. I'm going to put the voltage up. Apart from the door banging in the wind, you might hear some buzzing. The inverter. Now, my voltage isn't going up, my current isn't going up because it's set low. But my voltage is probably around about 15 or so now. So now I'm going to turn it up. So you can see now that I put it at the 16 volts, I've got almost 3 amps. It's going to keep on climbing from there because it's putting more current in and the voltage is unrestricted. However, if I restrict my voltage, bring it down again, my current has dropped off, and as you can see, this is a thing that's going to really happen with you when you're trying to make a battery charger or testing your battery charger. There is probably about a good 18 amps available, but I can't push 18 amps into this battery. So there you go. That's as simple as it is. A buck converter or MPPT charger will only charge at what the battery will accept, maintaining either a voltage, but with a current the voltage will rise up anyway. So this is where you need to think of, well, what's my solar actually doing? Although I've got hundreds of watts available, I can't actually put them into the battery because the battery will not accept them, and the battery is only saying, well, I'll have 1.6 amps, and that's it. Okay, I just wanted to finish off this video by doing the chemistry. I actually checked all my chemistry, so there you go. So you can check it yourself. Might need to pause it at some point to actually work it out. So anyway, the battery's holding charge and doing whatever now. It's been going on for a couple of hours. So what I've had to do is tweak the voltage up, lower it down a bit to the normal charger, which is about 40.6, We're going up to about 16.8, which is effectively an equalisation charge, which is always good. All the cells are bubbling away happily, and you know, that just saved me, well, it was a £270 battery, because it's one of those stop starts. So yeah, so here's a quick summary of this lot. I think the process is called redox anyway, from what I could see. What I did was the chemical compounds that we're using, so you've got sulfuric acid, lead sulfate, H2O, blah blah blah, all in there. So what we looked at, the hydrogen peroxide and the sodium chloride, the oxidizations on there, lead sulfate and hydrogen peroxide makes lead sulfate and H2O, or water. The sodium chloride mixed into that gives lead oxide, which is an oxygen, and so byproducts of sulfuric acid. The sodium oxide, which is an alkali, makes sodium peroxide and hydrogen peroxide, and the hydrogen peroxide is trisulfate, which is acidic, unstable in acid, which probably eats away at the crud build-up anyway. But as you go up, because you're using quite small amounts, it really shouldn't cause a problem. So when it's not charged, and it will neutralise itself when it's gassing anyway. So yeah, so just leave it. Mine was done yesterday. It was left from about 4 o'clock in the afternoon until about 9-10 o'clock the following morning. Even though we were using the hydrogen peroxide, and it was literally, it was breaking off the sulfate. You can see it crystallised in some areas, and it comes up as a white chalky substance, and it just floats around in the water. The gas bubbles up and breaks it all up. So yeah, we just had to bring up, this is the problem with sometimes, if you get a resistance build up in a battery, higher voltage can usually overcome that, and that will put charge in there, and then it's down to a couple of cycles then, using a equalising charge every now and again. After you discharge it, will usually break down the resistance to a degree. If it doesn't break down the resistance, the crud that builds up in the battery is sunk to the bottom, so you've probably got things like shorts and stuff like that in there, which will cause a problem. So I hope you found this video interesting, fun and informative. If you did like it, do click the like. If you like the channel and you like weird things, check the playlist and subscribe to the playlist, not the channel, because you can end up with anything on there really. Any questions? I know this was an answer to a question asked, so hopefully you found it interesting. I do a lot of different things, and by all means ask questions. A lot of people ask me how to build regenerative braking systems and things like that, but I'm rubbish at explaining things, but I can just know how to do it. It's part of a disability that I acquired. Okay, bye.